Okay, so sorry about that interruption. My camera feed just cut out as I was concluding that last problem, but fortunately I didn't say anything uh, really in addition to that after I was boxing 3x plus 4. So we're really ready just to move on to the next problem. So looking at number 12, we want to find all of this information about our given function. Um, so I'm going to write out our function. So we have that f of x is equal to 3x cubed minus 12x divided by x squared minus 2x minus 8. And what I want to do is first just factor everything that we have here. So notice that we can factor out a 3x from the top, and that gives us an x squared minus 4. And so if we factor it out completely using our difference of squares formula, we have 3x times x minus 2 times x plus 2. For the bottom, remember we want to find two numbers that multiply to negative 8, add up to negative 2. That would be x minus 4 times x plus 2. And so now that we have f of x factored completely, we can start to answer some of the important information from our function. The first thing that we want to do is find the domain. So for the domain, remember, first, we want to figure out all the places that this function is not valid for. So what are values of x that we can't plug in to our function because they'll give us an issue? And that's really when the denominator is equal to 0. So if the denominator is equal to 0, we'd be dividing by 0. We can't do that. So we want to figure out, well, where's everywhere that this function can't be equal to 0? So that amounts to solving for 0 for the denominator. Well, since this is already factored, we know that x can't be equal to 4, and x can't be equal to negative 2, because if we plug in 4 or negative 2, that's going to make either one of these 0. 0 times any number is going to be 0. We'll divide by 0 if we have x equal to 4 or negative 2. So our function cannot be equal to 4 or negative 2. So that means that on a number line, from negative infinity to positive infinity, any number is good except negative 2 and 4. So everything over here is fine. Everything in between those two is fine. Everything to the right is fine. So our domain is everything from negative infinity to negative 2, union from negative 2 to 4, union from 4 to positive infinity. And so this is our domain. The next thing that we want to calculate is our zeros. Well, first, let's calculate our holes. Because we want to remember, if we have a hole in the same spot as a 0, then the hole dominates. So notice that we have common factors of x plus 2. This means that we have a hole at x plus 2 is equal to 0, so x is equal to negative 2. So since we have a hole at x equals negative 2, for the zeros, and I'll start writing my answers up here. So the domain negative infinity to negative 2 union negative 2 to 4 union 4 to positive infinity. For the holes, we had x is equal to negative 2. And now for the zeros, we can find, we just want to figure out for the numerator where we have zeros. So let's look at this. We have 3x times x minus 2 times x plus 2. But remember, x plus 2, we can't have a 0 because that's already a hole. So really, all we have left to factor or to solve for, is the 3x 3x equal to 0, and the x minus 2 equal to 0. Well, for this one on the left, all we have to do is divide by 3, and we have x is equal to 0. And for the one on the right, we have x is equal to 2. So these two are zeros. So x equals 0 and x equals positive 2 are zeros. Remember, that's just solving for the numerator, and we have to exclude anything that was already a whole. The next thing that we wanted to figure out was a vertical asymptote. Remember, for vertical asymptotes, anything on the bottom is either going to be a whole or a vertical asymptote. So since this was a whole, anything that didn't cancel, in this case the x minus 4, that is a vertical asymptote. So we have a vertical asymptote at x equals 4. Horizontal asymptote. That's where we have to go back to this form that we have here and look at the degree of the top and bottom, see which one is bigger or are they equal. And in this case, the degree of the top polynomial is bigger, so it does not have a horizontal asymptote. Remember, in order to have a horizontal asymptote, these have to either be equal to one another or the bottom has to be bigger. But for slant asymptotes, remember, the degree on the bottom is 2 and the degree on the top is 3. So since the degree on the top is exactly 1 bigger than the degree on the bottom, we do have a slant asymptote. And so let's calculate that out. So how do we do that? So we're asking how many times does x squared minus 2x minus 8, how many times does that go in to 3x cubed? We're missing an x squared term, so we have to put plus 0x squared minus 12x and then plus 0 if we want to fill in our constant. I think that one's optional though. And so we ask ourselves, well, x squared times what gives us 3x cubed? Well, that would be 3x. We multiply 3x times all of this over here. That's going to give us 3x cubed minus 6x squared and then minus 24x. We're going to put all of that in parentheses and do subtraction. Remember that's minus out on the outside is going to flip the signs on everything on the inside here. All of this is going to cancel. We have 0x squared plus 6x squared, which is going to be 6x squared. And then we have negative 12 plus 24, which is going to be 24x. And then we can bring down the 0, and we have plus 0, so that 0 is not optional. So please write that 0. And then we repeat. We ask ourselves, x squared times what gives us 6x squared? That would be plus 6. And we can continue our polynomial long division, but it won't be necessary because this right here is going to tell us our slant asymptote. And so our slant asymptote is given by y is equal to 3x plus 6. So slant asymptote, y is equal to 3x plus 6. The y-intercept is pretty easy to figure out as well. Remember, for the y-intercept, all we have to do is plug in 0 into our function. So for the y-intercept, plug in 0 for our function. So if our function is f of x is equal to 3x cubed minus 12x divided by x squared minus 2x minus 8, if we plug in 0 to all of this, that's going to go away, that's going to go away, that's just going to be a 0 on the top. That's going to go away. That's going to go away. That's going to be negative 8 on the bottom. And 0 divided by any number is 0. So our y-intercept is 0, comma 0. So it is at the origin. So y-intercept 0, comma 0. Or you can write y equals 0 depending on who's asking. I personally like to write as a coordinate like that, but I think because it's specifically asking for a y-intercept, it is acceptable to say y equals 0. For the x-intercepts, really, they're kind of asking you a trick question here, because the x-intercepts are the exact same thing as the zeros. So we've already found that. X equals 0, and I don't know why I started to write a y, but x equals 2. Those are our x-intercepts. And for the end behavior, so the end behavior, we've already figured out what this function does with the asymptote. So we've already figured out that this function has a slant asymptote of y equals 3x. So really, we just need to know what is the end behavior of this function, because our function is going to follow y equals 3x plus 6. So if we know the end behavior of this function, then we know the end behavior of our full rational function. And so this function, remember, this is the parent function is y equals x. This just has a positive slope of 3, and it's been shifted up 6 units, but basically it's going to be shaped like this. And so we would say that the limit of f of x as x approaches negative infinity is equal to negative infinity, and the limit of f of x as x approaches positive infinity is equal to positive infinity, because again that corresponds to a function that has end behavior like that. And so that concludes how we find all of the important information for number 12. Lastly, we have the best part of any of these assignments, the test prep. So let's figure out the test prep. So the function f is a rational function. The quotient and remainder form of f is given by blah, 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 which describes the end behavior of f. Well, just like this last part, when we were finding the end behavior, remember, the end behavior is basically determined by whatever our slant asymptote is going to be. This right here is our slant asymptote. So if we know what this function looks like, then we know what our end behavior looks like. And because this is a line and it has negative slope, it's going to look like that. And so let's see, as x goes to negative infinity, as x goes to positive infinity, we just need this to be a positive infinity on this end, a negative infinity on that end. So positive, 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 negative. So our choice is D. Which of the following is equivalent to x squared plus 5x plus 2 divided by x plus 5? So what we can do is do synthetic division to figure that out. So remember, we negate whatever this value is. This is going to be a negative 5. And then we just need to list off the coefficients here. We have a 1, we have a 5, and a 2. And we just bring this number down. We have a 1. We have negative 5 times 1, which is negative 5. 5 minus 5 is 0. Negative 5 times 0 is 0. And 2 plus 0 is 2. This is our remainder, our constant, and our x term. And so what we get out of this is x plus 2 over x plus 5. And so our answer is C. The reason that I skipped over having anything, I just skipped from x to the 2 over x plus 5 is because we had a 0 for a constant. So really in it would be x plus 0 plus 2 over x plus 5, but we wouldn't need to write that, hence this answer. The last one is we have this function given by blah 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 as a slant asymptote of 6x plus 3. What is the value of a? Okay, so how we can set this up is, again, we're going to do synthetic division. We have we're going to write a -3, and then we want to write each of the coefficients that we have here. And just because it's an a, that's fine. We have a 6, we have an a, and we have a 2. And if we want the slant asymptote to be 6x plus 3, we basically need this value right here to be a 3. So let's see what value would make that happen. First, we bring down this. We have a 6. We have negative 3 times 6 is -18. And then what number, a minus 18, is going to give us a 3 right there? Well, that would mean that if we add 18 to both sides, a has to be equal to 21. So if we swap out 21 there for a, notice this would be a 3. -3 times 3 is -9. 2 minus 9 is -7. This corresponds to our remainder, our constant, and then our x term. And so we would have a slant asymptote of 6x plus 3 if a is equal to 21. So our answer here is D. And so that's how we do all of these. And so, yeah, thank you for watching.